All right, we have two more things that we have to do, and I'm hoping we can get them done in one video. The first thing is, obviously you've noticed that your circles are hanging off the edge of your surface. Some of you maybe not. Anybody not have their circles hanging off the edge? Probably not. Okay. So your circles are hanging off the edge of the surface, and we need to subtract the circles from the surface so that we can get a perforation, right? That's our objective. So our first step is to reduce the domain of the surface. By that, I basically mean we're going to limit the outer boundary of the surface itself. It can be done a couple of ways. I'm just trying to organize this a little bit. So it can be done a couple of ways, one of which would be to scale the surface. The other one would be to offset the outer boundary of the surface inward so that it makes it smaller, and then you can create a new one by a particular distance. So what I'm actually going to do is just that. I'm going to offset the boundary of the surface. I'll try it. It should work. This one's a little new to me. I haven't really played around with it this way before. So basically this surface, I can deconstruct it and get the edges. So under surface analysis, I don't know if that's what I want. Hold on. This one might be better. No. I might be changing my mind here. Alright, let's do B-rep edges. We'll try it that way. So, B-rep edges. No, I changed my mind. Sorry, guys. I'm just trying to get the right output. Wireframe curve should work. Let's try it that way. All right, so under surface analysis B-rep wireframe, I'm going to plug in the surface, and it gives me 4 line-like curves. So those 4 line-like curves are the outer edges of the surface itself. So what I can do with that, is to offset them. So that's under curve, either analysis or utility. I think it's under utility. Yeah, curve, utility, offset. Move this down. So it's going to ask me for the curves. It's going to ask me for the distance. It's going to ask me for the plane of operation. In this case, it's just going to match the surface itself. And the corners thing is just a setting for how you work on how you fix the corners up. So right off the bat, I'm just going to plug in my wires into the curves. And that is not at all doing what it should be doing. Oh, let me try plugging in the plane. So if I can borrow the frame. There we go. That did it. All right. I didn't think I was going to have to do that, but I do. So with the reason I grabbed that frame, so let me walk you through this. what was happening was that I noticed my curves were out of plane. And so one of the things we're going to run into quite a bit is that Grasshopper sometimes has a hard time ordering things, particularly with the direction of things. So sometimes if you have a series of surfaces that you're trying to offset, either outwards or inwards, occasionally you might get a surface of a group that offsets the opposite way. So sometimes it flips the normals, and it's one of those challenges that I haven't quite mastered yet. But anyway, what I tried was to predefine, because right now the plane is in the world XY, which means it's flat, even though my surface is vertical. So I figured if I took my frame, which is the evaluate surface frame right there, and if I made that my plane of operation, then it should straighten it out, and it did. That would be these here. Can you see them around the edge?
Yeah.
Now, the other thing about this is that it went outside of the surface, which is okay, but really what I want to do is offset it to the inside of the surface. So I'm going to, oh, you know what? I need something else. I'm going to need two of these. Yeah, I'm going to need two of these normal frames. Let's disconnect. Sorry guys, I need two normal frames because I'm going to create a separate surface. So let me move that down, and I'm going to copy the normal frame up. And I want to pause to make sure you guys get to this point correctly, because it's getting a little wild. All right, so I'm going to pause here, make sure you get to this point. All right, guys, back to action here. So what I've just done is I kind of took us on a detour, right? And I think before I do it, I want you to understand why. Okay? What I realized is that if I use the frame here, right, the frame of that, well, I guess, is that frame going to change? It might be a circular reference. You know what? I'm not going to worry about it. There's a chance it's going to be a circular reference if I modify that surface and then kind of push it back into the beginning in order to trim it down. Because our goal is we want to trim down the domain of this surface so that our perforation is fully within the surface itself. Does that make sense? So it looks kind of like this anyway. This frame is going to plug in there. So we've got our offset. And then we have to tell it how far and which direction. So the direction right now is 1 in the positive direction, which in this case, Grasshopper is telling us is outward from the surface. So what we need to do is limit the offset to go inside by changing it to a negative value. It's another important principle that I'm just freshly introducing, is that direction is mathematically positive or negative. Okay? So really all I need to do is create a slider, 0, less than 0.55, less than 2, something like that. And rather, technically you can make a slider that is negative, that's fine, but I want to use a positive number and transition it to negative. For no other reason than I want you to know that you can do that. Okay, so under math and operators, there's this cool component called negative, and all it has is one input, one output. It takes a number, converts it to a negative number, and pushes it out the other side. So now the x of 0.55 turns into a negative 0.55. and then we plug that in to distance. And what you see, if I put it up a little higher so it's a little greater, what you see is that the offset curves are now inside the surface. I wonder if this lets me do it with multiple curves. I've never actually used fillet before. I wonder if it works. I don't want to try that. So anyway, what we need to do now is create a surface off of these curves. So I'm trying to recall which one I actually used without having perfect corners. I think it was edge surface. Oh, I don't like that. Hold on. Multiple curves. Maybe I do need to fillet it. Hang on a sec, guys. I need to look something up. All right, I remembered the simplified way. So rather than trying to fillet the edges, which I recall you had to individually select one and then the other, and then fillet it, and then do that 4 times. Yeah, you don't want to do that. So the cool thing is, under surface and freeform, what you can test for, and this is more analysis stuff, okay? So guys, I'm running you through the gamut of like a bunch of different ways of thinking, okay? It's going to be mind-boggling, but check this out. With a 4-point surface, if I can just find the point of intersection of each of these curves, I can map a surface between those 4 points. Although, actually, it wasn't that one. I wanted to do... Darn, I just lost it again. No, it was... All right, so it was surface from points. It's pretty much the same thing, but 4-point surface is an example of what you'd have to do, but I didn't want to use that because you have to plug in each point individually. Don't want to do that. So with surface from points, basically any 4 points in space can create a surface. So I use surface from points, and it's going to ask for points as a list, and then a couple of other settings, which I'll get to. Surface freeform. But what I need is the intersection. The intersection of those curves, I need to get a point there. And this one is really cool, and it's our first foray into the Intersect tab. Under the physical panel, this one called Multiple Curves. So it says solve intersection events for multiple curves. Basically, if you look at the icon, it tells you everything you need to know. When I drop it in, it's going to ask for a list of curves, and what it's going to test it for really is just anywhere those curves intersect, and it's going to output points. It also outputs indexes of the intersections. Okay, so I plug that in. What you notice is that now there are points at the intersections. Pretty simple so far. With surface grid, I plug points in. Yes?
So flatten the C output, right?
Oh, did I flatten it? Oh, yeah, I did. Sorry, I did that before I started the video up again. Yes, flatten the C output. Thank you for picking that up. Yeah, you have to flatten it. Let me explain it this way. You have to flatten it so that it reads as one list, because if it's not flattened, each one of those items is only searching for an intersection within itself, of which it's impossible. Harrison seems really confused here. So let me describe it this way, okay? So the intersection test is going to test a list. A list. One list. If I plug in this, not flattened, technically I'm plugging in 4 lists. Now, it can run 4 lists, but it will run all of those 4 lists separately. So if those 4 lists only have one item in them, there's no intersection. It won't return anything because one item can't intersect with anything. Does that make sense? Okay, so that's why flattening and grafting and stuff becomes very, very important for a lot of things. So anyway, we flatten it. We get our intersections because now it's testing one list of 4 items. And we can plug that in. The P output, we plug it into the P input of surface grid. And the one non-intuitive thing here is like the number of points in the U direction. It's really asking you for, because what it's trying to do is technically create a surface from many points. And so it's going to test how many of them am I going to create a surface through. So if it's square and there are only 4 points, in the U direction, that means you're going across the surface one way. You're only going to 2 points. Yeah, very good. Very good observation. So put a panel in with a value of 2. Plug it into U. So that was under intersect and physical. All right. So real quickly, I'm going to turn a few things off. I don't think I need the outer wires anymore. I can turn off my offset curves. I'm going to turn off my evaluate surface. I'll leave the points on for now. So here's something that is very, very significant. And I know my video is getting long, but I want to just wrap this up in one thought. What I've done is replace the surface connection for all of these. The reason is that these surfaces are all mapped off of one, or rather, these circles are all mapped off of one surface. The exercise above limited that surface. So now my new surface connection is here. So my goal now is to disconnect all of the original surfaces and now reconnect them into this at the end. Does that make sense? When you see it, it will. So, all right. So this is how I'm going to do this. I'm going to make it kind of simple. This is a completed idea. So I'll group it. Oops. And I'm going to place a param for a surface. Now I described params to you before as an empty house for data. So if I have all of these wire connections, do I need to pause and wait for you guys? Yeah? Are you guys falling back? Okay. You guys can call out sooner if you need me to pause and hang back, okay? Because this is going to be important to know. So actually what I'll do is I'll stop the video here and I'll start a new one fresh for the last part.